Welcome to another episode of Federal Data Talk, the podcast where we dive deep into the rapidly changing world of data, especially in the public sector, with your host, me, Stephen Cole, an Azure DoD specialist at Microsoft Federal. Let's jump right in. But before we get started, got to satisfy the legal folks. Hit it.
The content provided in this podcast is for informational and entertainment purposes only. The opinions expressed herein belong solely to the individual host or guest and do not represent those of any other person or entity. All rights reserved. No part of this podcast may be reproduced, distributed, or transmitted in any form or by any means, including recording, photocopying, or other electronic or mechanical methods, without the prior written permission of the publisher, except in the case of brief quotations embodied in critical reviews and certain other non-commercial uses permitted by copyright law. For permission requests, DM the publisher on X, Federal Data Talk. The information in this podcast is not intended to be a substitute for professional advice. Listeners should not act upon any information provided in this podcast without seeking professional counsel.
Hey, listen, today's episode's a little bit different of a approach. We had John Dodson present cloud-native large language model ops with open source models at the AI Summit. So, although it's not a conversation, this is one that you're going to want to take a listen to. Now, as you're listening to this, the challenge I'm going to have for you is to write down some questions. Hit us up on X or leave a review. Write your question. We'll get back with you. But without further ado, smartest man alive. He doesn't like me saying that, but John Dodson, here you go.
All right. Good afternoon, everybody. My name is John Dodson. I'm a technical specialist here at Microsoft. And for the next 45 or so minutes, we're going to talk about LLM OPS, that is large language model operations, which effectively is how to bring large language models from experimentation environments to production environments. So we're talking about taking complex models and moving them to enterprise scale. Specifically, the agenda we have today, we'll talk about some definitions first and foremost. So understanding what large language model operations actually is, what it means. We'll compare and contrast that a bit with more traditional ML ops. There are some similarities, but also some divergences. We'll dig a bit deep into the actual life cycle of large language model operations. I'll keep it ideally a gentle introduction, but there are some nuances that we need to dig a bit deep into. Once we have our definitions and our concepts understood, we'll take a hard pivot and work through a notional real-world example, actually building out a workflow for an open source model, namely Mistral 7B. So we'll kind of collaboratively build out a workflow, taking open source, feeding it data, pushing it to a production state or an endpoint. Time permitting, I will actually show you what this looks like in implementation. But ideally, by the end of this session, you'll understand both the conceptual, the mindset behind large language model operations, as well as have an understanding of how to potentially implement it on the Azure cloud. So given that, we'll go ahead and jump right into our first definition, which is what actually is LLM OPS. The simplest definition, like the most foundational definition we can probably give, is effectively a series of methodologies for managing the end-to-end life cycle of a large language model. That includes developing and deploying. So unpacking this a bit, what does this actually mean? What does this actually entail? When you think about taking a fairly complex model like GPT, for example, there are a handful of considerations that a lifecycle management paradigm needs to take into account. First and foremost, I think obviously is the actual data and compute management. Training these models or fine-tuning these models, especially at scale, is a fairly compute-intensive task, right? Taking like Mistral 8X, for example, right? That's going to require some pretty bleeding-edge GPUs to even fine-tune or load into memory, right? Alternatively, not just at scale, but deploying, for example, small language models to like the forward deployed edge, right? So all these compute concepts need to be accounted for in a true life cycle management or a workflow. Beyond just, okay, cool. Beyond just compute management, taking into account workflow automation. So understanding how to craft not just various components of a life cycle, but a cohesive end-to-end life cycle in an automated fashion, right? So as we get a bit deeper into what LLM Ops actually is, we'll talk about the actual workflow steps and how these might be automated. Kind of pivoting a little bit from the workflow paradigm, understanding the various aspects and artifacts that go into actually using language models, right? So understanding, for example, how to optimize your prompts. Not all prompts are necessarily created equal, right? So a prompt that might work for a GPT-4 deployment might not be necessarily the same kind of performance for like Mistral or Llama, right? So a true workflow should take into account how to handle prompt variation. Model configurations as well. So the hyperparameters will, for example, differ between various models, right? So understanding how to seamlessly integrate different configurations into a generic end-to-end workflow. And then finally, the actual developer and end user experience. Anyone who's worked with me in the past will know that I am big on having the engineers and data scientists have a good experience. That includes understanding how to integrate all the dependencies, all of the actual dev environments in a cohesive way. So large language model operations as a workflow paradigm should effectively handle or account for the vast majority of these high-level concepts. So this is for language models in particular. Let's take a step back a little bit and talk about a more generic workflow for managing the deployment of machine learning, that is ML Ops. And I'm sure the vast majority of people in this room are at least somewhat familiar with this term. But essentially, ML Ops is a workflow paradigm to train, deploy, and manage the lifecycle of generic machine learning models, not just large language models. You can see on this diagram here, there are a handful of discrete steps that MLOps workflow should account for, right? And these are pretty, I think, generic here. So a data scientist pushes code. The code will invoke a training process. That training process should be validated. The validated model should be deployed and then continuously monitored. So MLOps workflows essentially look something like this. There's no real one size fits all, right? It depends very heavily on the actual dev team. From a Microsoft perspective, at a high level, most MLOps workflows for doing production grade machine learning take into account effectively these steps. Now, beyond just machine learning, right? If we take into account as well more generic software CI/CD pipelines, we'll see there's a very crisp alignment between the software dev process and the machine learning dev process, right? So what we have here is essentially a pretty close coupling, allowing software engineers and data scientists to collaborate closely as they build out these complex applications. The mindset here, of course, is that the machine learning models have to land somewhere in production, right? What happens when you train a model and want to deploy it? Well, it gets deployed to some downstream application for consumption, right? And the idea here is that by crafting a logical, comprehensive workflow, we can align the dev process for both software and machine learning. So double-clicking then into the various aspects that the MLOps workflow actually handles, we're going to think about it in terms of assets that get managed and features we expect the workflow to have, right? So this slide is not comprehensive, but it highlights a handful of the assets and features that we might expect for a production-grade workflow. Starting from the top, the various components of a machine learning operations pipeline. Um, Enterprise-grade machine learning should take into account things like execution environments. So, for example, making sure that your environment has the dependencies for TensorFlow or PyTorch, right? How do we actually manage those dependencies in their environments? By and large, they're Docker, right? But they don't have to be. But point being is that these model environments should be handled in some capacity. Code bases for your source code, of course, data sets you might need to train or fine tune, as well as the underlying trained model artifacts. So like, for example, the H5 files or the TensorFlow files, etc. Training and evaluation experiments for reusability and interpretability. How do you manage and monitor metrics while you save them off and you persist them? Those artifacts ought to be accounted for. And then, of course, the actual inference pipelines that you use when you push models to production. By and large, we'll consider these REST endpoints. They don't have to be. The idea is that the end state should be managed and accounted for somehow. And then very quickly, the features we expect to help us manage these. A production grade MLOps platform or pipeline should handle training and eval pipelines, that is helping us train these models and evaluate them at scale, helping us package them for reuse. So think, for example, training a model at scale on the cloud and then packaging it and pushing it to like the forward deployed edge, right? What does that packaging process look like? And then more of the administrative components. So monitoring and audit trailing, interpretability and observability, drift detection, all of these bells and whistles, if you will, would ideally be features that would accompany a MLOps platform. And then lastly, of course, the dev tooling that you might need to actually develop these models and these capabilities. So given all of that, kind of comparing and contrasting MLOps versus the more domain-specific LLM OPS, at first glance, like there is a lot of commonality here. The target audiences for these workflows are by and large the same, engineers and data scientists. The artifacts and assets you manage are by and large the same. The models in a more generic MLOps workflow are, again, more generic. So could be classification, regression, forecasting, et cetera. LLM OPS has to manage effectively one type of model, that is a large language model. But beyond that, the vast majority of these assets are the same. The first main divergence here is in the performance metrics. That's because, again, the MLOps workflow is intended to be more generic, right? So the classification metrics for, like classifiers or, regressors, et cetera. These metrics could be pretty broad, so accuracy or MSE, whereas large language models deal very specifically with human language. So the evaluation metrics are more tailored to human language in this case. And then, of course, the models that you actually deal with, not uncommon to find net new architectures, net new trained models in a MLOps pipeline. You will very, very rarely want to build a net new large language model. And typically, these are fine-tuned, right? So the pipeline workflow we're going to talk about is intended to fine-tune. And so, given all of that, we'll dig a bit deeper now into what typical large language model lifecycle might look like. We're going to think about this in terms of a series of iterative loops. These loops are going to correspond to phases of the lifecycle of a language model. And the first major loop we'll talk about is the actual data science loop. That is, understanding the business need to apply a large language model to a use case. The business need is, of course, informed by the data that you have. And then running an experimentation cycle, that is the true data science cycle, to understand if a large language model is conducive to your use case. So this is typically a matter of doing POCs or MVPs, understanding that your use case might benefit from a large language model. There are a lot of models out there. We'll talk about a few of them here in a bit. But ideally, in this first loop, you'll have a pretty solid understanding of what models might work best for your particular use case. Once you have an understanding, we can actually advance to the next loop, which is doing the actual engineering, that is building the system. So post data science exploration and experimentation, we advance to actually building out a comprehensive solution. This involves, of course, doing formal prompt engineering, that is tailoring your model, evaluating performance metrics at scale, applying perhaps even a RAG type process to understand how it performs on your particular business data sets. The point being here is that once you finish your experimentation, you want to build a comprehensive system. This is the system that you want to advance to a production environment, which leads us then to the next logical loop, which is operationalizing or productizing. So once you have your system or your model, you want to push it out to some end state. This end state is going to be consumed by an end user. Oftentimes, like we'll see this in the form of REST APIs. It could be applications, it could be SDKs. Essentially, whatever end state is most appropriate for your use case. And then, of course, understanding how to integrate all the bells and whistles, like content filtering for inappropriate contents, or monitoring and cost management, etc. So these are the three inner loops. The last loop I'll talk about is the outer loop, which is how to best orchestrate all of these concepts in an end-to-end fashion. So this orchestration is typically facilitated by a platform to help us actually implement the large language model lifecycle. So at a fairly high level, this is the generic end-to-end lifecycle for large language model operations. So the question now becomes, what tools are available to help us actually implement this? There are a lot. I'll talk about one in particular, which is PromptFlow. PromptFlow is an entirely open source tool. You can find it on GitHub. It essentially helps us take a code-first approach to building pipelines that deal with generative AI concepts. So think managing prompt variations, managing endpoint connections to large language models, composing sequences of steps in a logical sequential fashion. For example, this pipeline you see on the screen here is effectively a RAG pipeline implemented in a PromptFlow. So taking a fairly complex concept like RAG and making it, I think, fairly user-friendly via code. So in this case, we see the inputs. The input is then embedded. It is indexed. We generate prompts, and then we actually query the model. So PromptFlow has bells and whistles that help us craft these kinds of flows. I'll show you one that is actually implemented for our particular use case when we move to the demo. Okay, so that was kind of a crash course through LLM OPS as a concept. We'll pivot a bit now and work through actually building a workflow with Mistral 7B. So on the Azure cloud, there are effectively two ways to interact with large language models. You have, on one hand, of course, Azure OpenAI, which is our production-grade API, exposes GPT models, etc. The other primary way is through the various open source models we have first-party support for. So the foundation models on the Azure cloud are illustrated in part here. We curate them from Hugging Face, from Mistral, from Meta, from NVIDIA, and a handful of others as well. So point being is that we have a pretty solid open source community support here. The model that we're going to focus on for our use case is going to be Mistral 7B. So we're going to pull out Mistral 7B and kind of work together to craft an end-to-end pipeline to push Mistral 7B to production state, as well as account for the various components that we expect in an end-to-end lifecycle workflow. So let's go ahead and start by pulling out Mistral 7B. The task that we want to apply Mistral 7B to is effectively Wikipedia summarization. So think from an end user perspective, I have a chat interface. I type it, maybe a very broad or generic question. We want Mistral 7B to be grounded in Wikipedia and respond to my question with sources ideally. So what does that actually look like in implementation? As I mentioned before, the end state for a model is typically some kind of an API. So first and foremost, we want to take Mistral 7B and push it to an endpoint. This endpoint is going to be REST, so a simple REST API. We like REST, obviously, because it can integrate with virtually anything, right? Any JSON consumer is fair game here. So the first major milestone is to push Mistral to an endpoint. Now, keeping in mind the actual task, it's not a very trivial task, right? So we can't just push the model to the endpoint by itself. So prior to pushing it to the endpoints, we're going to first apply it to a prompt flow inference pipeline. So I'll double click into this in a second, but the point being is the model itself is not what gets pushed to the endpoint, but the prompt flow inference pipeline is what gets pushed to the endpoint. So all the complex logic that's involved with grounding Mistral on Wikipedia is what gets exposed via the API. So beyond just the actual endpoint support, the vast majority of production grade model workflows should incorporate a handful of different features. So the most popular one, the most important one, is going to be the model repo. So effectively, what happens when we want to persist our Mistral, right? It has to actually live somewhere. The model repo is where it would actually live. So the actual underlying model artifacts would be persisted in the repo. So next question is, how do we actually get a model into the repo? We'll talk about this in terms of two discrete compute processes. That is the fine-tuning pipeline and the evaluation pipeline. So why do we decouple evaluation from fine-tuning? So the idea here is that the fine-tuning pipeline actually generates a net new Mistral version from your data. Obviously, there is fine-tuning involved in that, but we want to decouple the pipelines because as the production state consumes data, we want to monitor for drift and performance and be able to invoke ad hoc evaluation steps. So the actual fine-tuned Mistral is what gets fed into the eval pipeline. Now, the question is, where do these actually run? So we're going to go ahead and apply a GPU compute cluster to our pipelines. Mistral 7B is not quite state-of-the-art, right? But it still requires some pretty beefy compute. So we're going to set up a GPU compute cluster to actually run these processes for us. And then, of course, apply an input data set. In this case, it's going to be our business data, right? So conceptually, whatever data you want to apply to your model for fine-tuning would happen here. This looks pretty good so far, right? So the last missing step is, of course, the monitoring. So we're going to plug in a monitor at our endpoints and monitor for things that I mentioned before. So performance metrics, any kind of data drift, et cetera, and link that back to the evaluation pipeline in case we need to reevaluate or refine-tune our deployed model. So this is effectively the end-to-end pipeline for managing the lifecycle of Mistral. Now the question is, where do these features actually exist? The endpoint model repo, and the monitor are all going to be built-in features for the Azure Machine Learning Platform. The fine-tuning pipeline and the evaluation pipeline are going to be custom developed and executed on the Azure cloud. So most of the critical features here are going to be accounted for kind of automatically as features. And there is some custom development between the pipelines and the inference flow that will have to happen. So double-clicking into the inference flow here, the actual prompt flow inferencing, how do we actually handle doing Wikipedia summarization? The prompt flow pipeline that I'll show looks basically like this. So user types a question. From that question, we're going to extract entities, or I guess topics, if you will. We're going to use those topics to search Wikipedia via the API. We're going to fetch the articles, we're going to process them, and we're going to ground Mistral. And then Mistral is going to answer our question and return it as output. So fairly complex process made pretty high level and seamless via prompt flow. So before moving on, the question here is, what does it actually mean to extract entities? So entity extraction is a pretty foundational task in NLP. There's effectively a lot of ways to do it. To kind of show the flexibility of prompt flow, the flexibility of this particular platform, we're going to use Azure OpenAI to extract the entities for us. So what we have here is effectively interplay between Azure OpenAI and Mistral, all in one cohesive end-to-end pipeline. And we'll see what that looks like here right now. So I'm going to hop over to the actual demonstration. Before I do, are there any questions about what we're going to see, the actual flow? If not, that's fine.
We do have one up here.
Yeah.
What do you mean by Azure OpenAI? You doing semantic search on a certain LLM or what?
Yeah, so Azure OpenAI is going to be the actual PaaS service, the actual platform service that exposes that API for GPT-3. So we're going to query GPT-3, send it our question. It's going to return a list of entities for us.
Does it create multiple queries? From the one prompt, does it input?
Yeah, so it will return effectively a list of entities, right? So if I ask it a question like, what is a neural network, for example, it's going to return neural network as the entities, and we'll use those terms to search Wikipedia.
Oh, okay.
Yeah. So I'm going to reshare my web browser here. Okay. Should be coming up. Okay, so real quick, what you see in front of you is the Azure Machine Learning Studio. This is effectively our flagship product for managing machine learning tasks. So considering all of the concepts that I mentioned before, so things like data set management, asset management, environment management, this particular service is the Azure way to manage all of those. So we can see on the screen here, we have the various assets from endpoints to models, et cetera. We have the integrated developer environments, as well as the compute management features as well. We're going to start from the end state and work backwards a bit. So again, the Mistral Wikipedia summarizer is pushed to an endpoint. Our endpoints are managed here. If we click into here, we see I have quite a few. So we're going to look at our WikiChat Mistral. This is, of course, a chat agent using Mistral 7B backed by Wikipedia. If we click into this endpoints, we'll see we manage a handful of different endpoint attributes. The most important one is going to be the actual REST API. So taking this API, if you were to deploy this particular pipeline, you could take this API and then use it in whatever downstream application can consume REST, right? So if you had an application you wanted to integrate into, this REST API endpoint is how you would do it. Beyond that, we can also test directly in the studio here. So going to test, I have my nice chat view. This is going to effectively invoke that prompt flow process that I showed on the slides. So if I ask it a question, what is phototropism? This is going to go back behind the scenes and invoke that end-to-end process. It's going to take that question, extract the term phototropism. It sends it to Azure OpenAI GPT-3, searches Wikipedia, and then grounds Mistral in Wikipedia, and then returns this summary of the phototropism definition. If I ask it separate question, what is a neural network? It's going to invoke the exact same process and return a definition for neural network. About half the time, this actually cites its sources. So let's see if it actually cites its sources. So if I ask it, what are your sources? Let's see if it actually cites its sources here for where it actually got that definition. So it does maintain chat context as well. So it actually has the Wikipedia link to the definition of a neural network here. So this is what the end state looks like. So in terms of implementation, we can actually go to the prompt flow user experience here. I mentioned prompt flow is an open source tool. We do have first-party support for it on the Azure Machine Learning Platform. So if you go to my prompt flow tab here, we can pull up the actual flow. I have WikiChat Mistral 7B. And what we'll see here is a nice developer experience that lets us actually author these pipelines and render them as nice graph views. I'm not going to walk through any of the code, obviously, but I do want to bring you to your attention the pipeline here. So this is going to look pretty similar to what I had on the slides. So user inputs to the query extractor, fetch from Wikipedia, process, and ground in Mistral. I mentioned, of course, it is a code-first tool. So kind of scrolling through the developer experience, we have integrated Python tooling all the way down to where we actually invoke Mistral. So Mistral Augment is an API. This actually takes the context that we get from Wikipedia, applies it to Mistral, and runs the inferencing. So this is the prompt flow inference API, right? This is what actually gets deployed to the endpoint, and we invoke this when we chat with the model. Now, what about evaluation and fine tuning? So the model catalog, if we go to the built-in model repo under models, we can see, not save. We can see I have quite a few different models that I have registered here. Mistral 8X, a few versions. Mistral 7B is the one we're using here. So the question is, how do I actually evaluate or fine tune this model that I have persisted? Within this particular tooling, we can craft pretty logical workflows to do operations like evaluation and training. So the experience here looks something like this. In my pipeline designer, I have two that I'll focus on, Mistral 7B evaluate and Mistral 7B fine tune. So clicking into what the pipeline looks like, we're greeted with a nice canvas view. When we register pipelines to execute complex model processes in this tool, they get rendered to the end user as this kind of a nice UI, right? All these modules you see are backed by code. So we have the data that we feed it, we have the actual model, and we have the pipeline operation that will actually execute. So double clicking into the actual pipeline, this gets a bit more complex, but the steps are very logical for doing evaluation. So we see things like model predict over our data, compute the metrics, and then dump the evaluation output for further analysis, right? So these very discrete steps are what executes when we invoke this pipeline. I'm not going to run it in real time because it is a bit slow, because Mistral is quite big. But if one were to run this, the metric outputs would be dumped to a storage account for further analysis, for example. Yeah. Yeah, so this is going to be separate from what happens in prompt flow. Prompt flow is for handling effectively the inferencing process, right? Doing the actual metric computes for evaluation is going to be a separate programmatic process. So the code that backs all of these modules is not part of prompt flow.
But did you have to build this, or this get part of the template from Hugging Face, or available within ML?
I will touch on that in a second. Yeah, that's a good question. So before I pivot to that, let me go back and show the fine-tuning pipeline. The same fundamental concepts. We have the canvas view, we have the high-level view. Double-clicking into the fine-tune pipeline itself, this gets significantly more complicated, but the steps themselves are still, I think, pretty logical. So importing our model, pre-processing our data, actually running the fine-tuning, and then doing the built-in inferencing or built-in evaluation. So again, these modules are backed by code, but to Brandon's points, within this particular tool, we make it pretty seamless to actually deploy pipelines like this. So I mentioned the model catalog. That is a built-in feature in this UI. So if I go to my model catalog tab, this is where the open source models that we support are rendered to the end user. So we have effectively a nice marketplace for pulling in open source models. By virtue of being open source, if a user were to pull in a model like, for example, go to Mistral, where's 7B? Mistral 7B. Users get access to the underlying model binaries. And what that means is that if you wanted to take this model from this catalog and use it in, like, for example, your own proprietary API, or use it off of the cloud, you could. So we have the model details here, we have the URI to access it, and critically, we have the artifacts tab. Going to artifacts, we're greeted with a source tree, and here are the actual model binary components. So if you wanted to load this into Hugging Face, that is totally fair game. So lots of different flexible ways to use the open source tools we have available in this particular service. Now the question of how do we actually render the evaluation and fine-tuning pipelines, it can be one click deploy. Fine-tuning gets turned off sometimes for Mistral. I'm not entirely sure why, but for Evaluate, if I wanted to deploy a separate evaluation pipeline, I can do it through this click-through experience or wizard here. So the pipeline that I showed you can be automatically generated through this UI. And the same is true for the vast majority of the other open source models we have as well. So just kind of scrolling through the various offerings, from Hugging Face, for example, very, very foundational models like GPT-2 or BERT or T5, encompassing a vast array of different use cases, summarization, translation, entity extraction, etc. Lots of different use cases here.
When you import a model, does Studio allow or show you something to say, hey, the way you provision, this thing is going to be slower than dirt. You need to adjust your provisioning to give you optimum performance?
Yeah, so I guess there are two parts to that. When you import a model, the onus would be on the user who imports it to state very clearly what the compute requirements are to actually run fine-tuning or evaluation or inferencing. All of these models you have here are going to have requirements for compute. So if I were to go, we can do this in real time. If I were to go to like Mistral, for example, and go to a big one like Mistral 8X, if I wanted to deploy this to an inference endpoint, I can go to my little deploy button here. And it gives me a list of VMs. And so this list of VMs is, of course, very limited. I have basically three options, right? So we're not going to let users, for example, deploy this on like tiny CPU VMs, right? So any imported model could have a very similar restriction for compute. The expectation would be that whoever imports the model would know the performance way to run. So that responsibility would be on the user who imports. But for pulling models from the catalog, we'll kind of guide you along with the compute requirements, if that makes sense.
Yeah. Some of those compute there, is that the same compute in the blade settings? Is that kind of right? That same computing?
The compute you see here are the options for that dropdown.
So that's great. Different.
Like under here, for example? Yeah. So these are computes you actually have provisioned and use, right? So if you wanted to spin up a compute cluster that is dedicated to using Mixtral, right, you would have to spin up a cluster that is basically one of these three options. These options, when you actually provision them, would be managed through this tab. Yeah.
Notice that the URL is .com and not .us. Is the smart catalog available in US Gov? Well,
yeah, so everything you're seeing here is available in Azure Governments. It is available in preview in Azure Secret. So the features you see here are available across our multiple clouds. Yeah. So I think I have like 5 minutes left. This is basically the LLM OPS brief. Are there any final questions or comments?
Yeah, so I was wondering about governance, because that is a big kind of deal, the traditional MLOps life cycle. And then as we extend it to LLM OPS, does Azure have any capabilities for like adding evidence? Hey, by the way, this is the use cases these models are approved for. This is, the model card, things like that.
Yeah, that's a good question. The question of governance can be handled a handful of different ways. I don't know if I have an example of this in this environment, but within this particular service, we have the ability to build pretty sophisticated dashboarding tools. So for example, if you wanted to monitor like the usage of your particular model over time as it's deployed for inferencing, we can effectively set up hooks to render nice visualizations for analysts to understand like performance, et cetera. In terms of like monitoring, like just apart from this particular service, the nice thing about Azure Machine Learning is that it integrates pretty well with virtually every other like Azure data service, right? So hooking this up to Azure Monitor is fair game as well, or even maybe something open source like Grafana, right?
Yeah, so lots of, for the most part, that's going to be kind of tied to, for example, let's say that the accuracy goes down or something like that, right? Then we have this from there, but nothing really for, I guess, who and when should use the model, kind of that governance documentation, or what is the prompt, or what are the procedures that people must follow to kind of use this model? Because, in an enterprise, not everyone is able to, get the training they need and everything like that. So
yeah. Okay, yeah. I think you're talking about like understanding the various user personas that would have access to. Yeah, okay, got it. That would be, I would think, probably a manual process. Responsible, I guess, the responsibility of the administrator who grants access to the service overall, right? So this integrates as well with Active Directory, right? So no issues restricting various components or various features of the service by virtue of Active Directory. The governance of the models themselves, I think that's pretty well handled via the model cards and the monitoring, et cetera. But user access would come from Active Directory permissions, right? So an admin would ostensibly know, who belongs in what group to access what features, right? Because you don't want like a non-data scientist to pull down like Mistral and try to run it.
You said broad use case that it's not heavy, right?
Precisely. Yeah. So I think the answer to your question is I believe it's doable, but it's going to be, I think, the responsibility. Correct. Yeah, that's fair. That's fair to say.
Thank you for tuning in to another episode of Federal Data Talk. Hopefully you've gained valuable insights and inspiration to fuel your journey into the world of data. Join us for new episodes, but don't forget to like and subscribe. That way you don't miss it whenever we release them. for thought-provoking discussions and interviews with industry experts. Thanks again. We'll see you soon.